Hey, greetings, y'all. My name is Brad Vander Zanden, and this is hopefully, well, not hopefully, this is CS140. I say hopefully because hopefully you are in the right location. So this is the first of a two-course sequence, which is an introduction to data structures and algorithms. The second course in the sequence is CS302. And after CS302, you actually start to branch out into the required and elective courses. So you've been on kind of a tight pipeline, and we're approaching the end of that tight pipeline with CS140, and it will start to branch out once you get to 302. But before you can get into the heart of the CS curriculum, we have to teach you about data structures and basic algorithms. Now, thus far, you have had an introductory programming course, and presumably, most of you have had the computer organization course that gives you an idea of how the computer works at the machine level. And so, with those two foundational courses, you're now ready to learn how we organize data and make it easy to search and to find things. So this course is fundamentally about how we organize data and that is going to involve three fundamental operations that we will revisit time and again this semester. And those three operations are going to be insert, delete, and find. So this course perhaps can be boiled down to these three operations. And the reason we want to do that, when you Google something, you're looking up information, you want to find something, and Google faces this problem every day. How do we insert new data from the web into our databases? How do we make it easy for people to find data in our databases? And how do we, on occasion, delete content from our databases? Same thing, when you go to eBay or Amazon to make a purchase, you need to be able to find product. Amazon needs to be able to insert new inventory into its databases, and it also needs to be able to delete discontinued inventory. So these are three fundamental operations that occur again and again throughout your computer science career and that are fundamental to companies in the computer science industry. So this course is devoted to that. When you get to 302, we broaden things out a bit. I'm not going to really talk in this course about what we cover in 302, but that's the basic idea about the course. Now, before I go further, I actually see one of my TAs back there. It reminds me, Ryan, stand up. This is Ryan Flint. Many of you met him yesterday. If you didn't, he's one of the 4 TAs for the course, and get to know his face. He'll be in the programming clinic, and he will be with you in lab sections as well. So thank you, Ryan. So this then continue. Yeah, Brian, you can take off. So then more broadly, we have 4 objectives in this course. So this is what the course really concerns, but we're not actually going to start with that. We're actually going to start with a different goal, which is to review C++. Actually, the first month, we're going to be reviewing C++ because while you had some programming experience in 130, it wasn't as extensive as it was in 102. We found it's good to review 102 and also introduce you to some additional concepts that you may not have seen. So another one of the objectives of this course is for you to start becoming self-sufficient C++ programmers. And that doesn't just involve reviewing what you already know or should know, but it involves introducing some new constructs. So in this course, you'll learn about something called pointers. You'll learn about another technique called recursion. So there's some new programming techniques you're actually going to learn in this course that will actually help with the data structures that we'll be covering. But we also want you to become better at, did I get it? Yep, problem solving. So in 102, we're just trying to get you up to speed with the syntax of programming languages and get you to be able to write basic programs in them. And we don't actually have you do a lot of problem solving, which involves designing a solution to a problem. We give you most of that design, we prescribe it and say, here's the design, now implement the program. We'll still be doing that somewhat in this course, but you'll have more latitude to design your program. We won't be as prescriptive as we were in 102. And problem solving is an important skill that you will get better at as you proceed through the curriculum. It's not something most of you will be instantly adept at. It's one of those practice things. The more you practice it, the better you get. Okay, so many of you will find it a struggle on certain labs, figuring out how to put the pieces together, and for that we have me and the TAs to serve as your guides. But that's one of the, when we say to become self-sufficient C++ programmers, part of that is problem solving. And then you can see there's actually 5 things here. Some of these, like compiling and linking, you already did a bit of in CS102. Setting up data structures, you did a bit with arrays and classes. Certainly organizing the I/O, you did that. In this course, we start getting more into some libraries. You use some libraries as well in 102. You'll use them more extensively. But what you'll really do a lot more of here as well is debugging. So that is when your program doesn't run, there's some flaw in the program, you need to hunt it down. It's much like being a detective. Looking for clues, taking advantage of the clues you're provided to try to find what is causing the problem and fixing it. So all of those things, problem solving, becoming better at debugging, learning some new concepts and polishing up the skills you already know are all part of this becoming self-sufficient C++ programmers. Then the second objective is what I just was talking about, is what is the kind of core of this course. It is how we organize data and do so that we can insert, delete, and find efficiently. And there's different ways of organizing data. So different what we call data structures and different trade-offs with each data structure. So a data structure should, since that's such a basic part of this course, let me define it. A data structure I'm going to say it's a way to organize data to support certain operations efficiently. And in this course, those 3 operations are insert, delete, and find. You already have some experience with data structures. Arrays and vectors allow you to organize homogeneous data, like integers or floating point numbers. Structs and classes allow you to organize heterogeneous data. That is, data that's not of the same type, like the information on a driver's license or your student information. So you've already had a basic introduction to data structures, and in this course we build on that. Okay? Then we say a key word here was to support certain operations efficiently. Well, how do we know whether an operation is efficient or not? The way we know is by doing something called algorithm analysis. So we did define an algorithm in 102, but let me do it again. An algorithm is I'll call it a recipe or series of steps for solving a problem. So when I talk about problem solving, what I'm really talking about is the ability to formulate an algorithm that can solve a problem. And then when you write a program, that is the realization of that algorithm in a particular language. Algorithms are language independent. You can implement them in C, in C++, in Java, in Python, in Ruby, your favorite programming language. So algorithms are language independent. They're just a series of steps for solving a problem. And we use these algorithms to implement operations on a data structure. Well, in order to be able to know whether it's been implemented efficiently, we have tools that allow us to analyze algorithms. And in this course, we'll start introducing tools for analyzing algorithms so that we can predict their running time. What we care about typically is the running time of an operation. The faster the operation, the happier we are. So algorithm analysis is essentially the art, or really we want to make it the science, of predicting the running time of an algorithm given a certain size of input. And the size of the input will matter because some algorithms do very well when the input size is small, but when there's a large number of input elements, they become inefficient. So being able to predict the running time of an algorithm, we often need to know the size of the input. That is the parameter to the function. And finally, the fourth goal is for you to become familiar with using command line tools. And that process started yesterday in lab. It may have been jarring for you, but it will get better with time as you become more familiar with these command line tools. So in 102 and 130, we let you use graphically oriented tools. You use the Windows operating system, which is a graphically oriented operating system, because you're able to click on things in order to make things happen. Like if you want to navigate through a file system, you click on a series of folders. If you want to open a document, you double click on it. You want to delete a document, you drag it to the trash. But you're doing all that graphically. Same thing when you were coding. You used an integrated development environment called CodeLite, and it provided commands for you to compile or to run your program. It often provided command completion for you. When you had errors, it would often highlight the statement that had the error message. That's all well and good. In fact, many to most of you will use such integrated development environments when you start jobs. But many other of you will not. You'll use what are called command line tools, which you were introduced yesterday in Lab 2. We will use the UNIX operating system in this course. And we will use, so Unix will be our operating system. And you will use command line editors. We recommend VI or Vim, although you're free to use something like WordPad or TextEdit. But we think it's a good idea if you get used to a command line tool like VI or Vim. The reason is going back to a critical difference between something called recall memory versus recognition memory. So we digress for a moment into cognitive psychology, but it's an important digression. So recall memory is your ability to recall a fact without my prompting you. If I ask you what year was the Declaration of Independence signed, I'm asking for recall memory, and it is 1776. Most of you have it indelibly inked in your mind. That's recall memory. Recognition memory is memory that serves you when I prompt you. So I might give you 4 choices for the Declaration of Independence. I might say the Declaration of Independence was signed in A, 1492, B, 1776, C, 1861, and D, 1942. Now I'm asking you for recognition memory. Many of you might not remember precisely that it was 1776, but most of you could probably pin it down to the 17th century. And so when you saw 1776, you say, that's it. That's recognition memory. So intermediate and novice people use recognition memory. Experts use recall memory. Recall memory is much faster. And that's why we want you to get used to using recall memory. Well, what uses recall memory? Command line tools like VI and UNIX. Okay. So let me give you an illustration. If you are in a file system and I want to find, say, my notes for this semester, I first have to figure out where CS102 is. So I'm scrolling. CS140, there it is. Now it's spring 18, there it is. And the notes actually aren't here, but you already saw the point. I was having to look through my screens trying to find it. But with Unix, it's very simple. I say command cd cs140 fol 18 because I know that is the series of so-called folders that I need to use to get to my directory. Boom! I did that in like 2 seconds because I knew which folders I needed to go to, and I just typed it out, which is faster than having to move my finger on the trackpad. Okay, in fact, every time you take your fingers off the keyboard, you do what is called a context switch. And it takes roughly 15 seconds for your brain to re-engage with the previous task. So when you take your fingers off the keyboard, you have to go to the trackpad, find the trackpad, then maneuver the cursor to the desired command, select the command, then reposition your fingers on the keyboard, and again, reacquire the task you were working on. When they measure this, cognitive psychologists measure this, generally you lose about 15 seconds. Okay? So recognition memory isn't so good for experts. It causes you to lose a lot of time when you know exactly where you want to go. Now for intermediate users and novice users, recognition memory is great because you don't remember the commands. You'd have to look them up. In that case, having a prompt such as, I don't remember what the command is for, let's say in Word, I can't remember what the command is to open a file. Oh, there it is, open. Now I know what I remember. I've been prompted. So recognition memory works well for intermediate and novice users because frequently when prompted, when they're given a series of commands, they can pick out the one that they want. And graphical editors are good for that kind of memory because they provide menus and toolbars that prompt you. Whereas command line tools aren't. They just give you, blah, it looks like a lot of stuff here. And each one is the response to a command that I typed in. But you have to memorize these commands, and at first that's going to be a problem for you. There are commands in VI you have to memorize, commands in Unix, and at first your productivity is going to take a hit, and you're probably not going to be happy about that. Okay, you think, why can't we use a better system like Windows or the Mac? Why can't I use an integrated development environment? But as you learn and memorize these commands and they become second nature to you, you will find that you become much faster programmers, more productive programmers. And that's why the fourth objective of this course is to make you familiar with using command line tools, because those tools make use of recall memory, and recall memory is what experts use. And it will make you much more productive programmers as you master these command line tools. Okay, so those are the four objectives for the course. Questions about that? Okay. So let's take a little time then to talk about logistics of the course. So what to expect, where to find things, what about the textbook? So to begin, the website for the course is web. Let me write it out because it may be a bit hard to see. Website for the course is web.eecs.utk.edu/tilde-bvz. That's a tilde. I didn't do that too well. CS140. And soon it will be in the course links for the department. You can find it there, but not a bad idea to bookmark this either. So this has pretty much a landing pad for the course, and on it you can find pretty much all the course information. Now there are two other places where there is course information. One is Canvas. So Canvas will be where you submit your lab assignments and where you see your grades. Although that will pretty much be it for what we use Canvas. And then you were introduced yesterday to our discussion board for the class, which is Piazza. So that's where you'll be able to post questions. And that's where I will post answers to questions, where I will be making announcements. Sometimes I don't say something the way I wish I had in class. I'll be making corrections there. I'll be amplifying on data. So Piazza is where we hold our discussions out of class, where you can get help during non-office hours. So those are the three big sources of information for the class. So where to find things. So course information, my office, Mincal312. Here's my email address. Now in general, I prefer that you post questions to Piazza, because if you have a question, chances are there are several other people in the class that have the same question. I'd rather not answer it multiple times. Now if you have a personal issue, by all means, I'm the one you should email. If you have a late lab that you need to discuss, that should go to Camille Crumpton. So late labs, you should contact Camille Crumpton about. And her email is ccrumpto@vols.utk.edu. Now, I have a late lab policy. In general, you simply will submit a lab late and you'll have some points deducted. Very rarely will we give you a ability to extend the deadline. But sometimes there are very extenuating circumstances, and if you feel you have one of those very extenuating circumstances, you can get in touch with Camille. The chances are she will say no, because I've told her to generally say no. I expect you to get started early on labs, and if you put something off to the last minute and you get the flu, you have my sympathies, but you did put it off to the last minute, and you could have started it earlier. Okay? So usually it's something that is going to be a week or two, like you have some issue that takes you out of school for a week or two that's going to get you an extension. It's not going to be, I caught the flu. Well, that's an issue we just generally deal with, and as I say, you can talk to her about it, but we do have a late lab policy, and also I drop a lab. So there's a lot of that's not quite true. I actually give extra credit for labs. There's one extra lab. We'll get to that when I get to it. But at any rate, there's a lot of reasons why I generally won't give a lab extension. Okay, so getting back to things, the textbook is an ebook. So it should have been paid for in your fees, and it's called Programming in C++ and Data Structures. It's by a company called Jan11. And you should be able to access it by going to zybooks.com. So it is, you can read that, zybooks.com. And you should be able to create an account. And once you do that, if you give this code right here, you should have access to the ebook. Okay. We may have to, the last time we used it, we had to sometimes work with the university library to get some of you set up. For the most part, it went pretty smoothly last time. Hopefully, it will do so as well. You click subscribe, and they may or may not ask you some questions, but which you can answer, and that will get you in there. This ebook is an interactive ebook. It asks you questions after each. It generally talks a little about a topic, and then it has what's called a participation activity. I assign these participation activities and expect you to complete them before class. I find, now there's a reason for that. I run a class that's somewhat different than the one that you are used to. I flip the classroom. A flipped classroom is one where you tend to do hands-on exercises in class. So I will be probably many times lecturing only for about 30 to 40 minutes. And then I will be having you do programming activities, which will also be from this ebook. So this ebook is going to be an integral part of the course. You're going to need to, first of all, read up before class and answer participation activities that will help you work some of that material. They're easy in general. So that when you come to class, you're prepared for the material that day. So I don't have to lecture on the entire class over the material. Instead, I can hit the high points or work out some examples. And then the second half of class, I can have you work on some challenge activities from the book, which tend to be some short programming assignments. Now, why do I do it this way? The reason is that it's well proven now, again by cognitive psychologists, that the way you learn is by doing, not by listening. So passive learning is much inferior to active learning, and pretty much the lecture model has been shown to be one of the worst ways to have you learn. Okay, now that influences the way I teach. If you're still skeptical, think about certain activities where you may have watched an instructional video, like riding a bike. It probably looked really easy when your parents did it, and then you got it, and even your parents said, oh, it's easy, you just get on, you balance, you spin the pedals, and what happened when you got on? Bam, straight over, because that wasn't in your muscle repertoire at the time. So the only way you got better at it was you had to start trying to ride it yourself, and you'd fall, but you got better. Same thing, I'm a golfer, and I can watch Tiger Woods swing in his videos, and it looks great. And then I go out, address the ball, and swing, wham! It goes nowhere, I actually whiffed. Okay? The way I learn is that a golf instructor sits there examining my swing and says, oh, Brad, you looked up. You wanted to see where the ball was going. It's down there because you looked up too soon, and when you looked up, you jerked up the club, and the club went over the top of the ball. So the instructor sits there, helps me to learn. Well, that's in effect what the flipped classroom is. Okay? You're able to work, and in fact, in class, I'll allow you to work in pairs so that you can help each other. I will circulate. If you get stuck, I can try to unstick you. If I see a problem commonly occurring, I can stop everyone and say, hey, here's a problem that's occurring. Here's how you solve it. So instead of you spinning your wheels, not knowing what to do, I quickly get you over the hump and to the next problem. And we often go over the solution, so even if you don't get all the way through it, you see how it was done. And by having actually tried it, you've actually engaged in it, you've worked those muscles, and now when I show you, hey, here's the right way, sometimes the light bulb goes off much more quickly. When I've tried this approach in CS102, the grades, overall course grades, have gone up from 1/2 to 2/3 of a letter grade. That's pretty impressive. And other people at other universities have had similar results. So this ebook, though, is critical to that because in order to have you work those exercises in class, you need to come to class prepared. The way that I can try to force you to be prepared for class is to at least make you do those participation activities. Now, this textbook is different in another way from traditional textbooks. It's aggressively minimalist. They know that many of you don't like to read, that that's not the way we typically get information, or that attention spans aren't what they once were. So the sections are short. They get right to the point. They give you some quick examples, and then they test you on it. And the participation activities you can do quickly. So this isn't going to be long, meandering prose. They work very hard at making it short and hard-hitting, getting to the point, then moving on. Okay, so when you see something, these chapters aren't nearly as long as the chapters you're used to reading. You'll get through the sections much more quickly, and the participation activities will help you with it. So I don't think it's going to be a huge burden. Have to look at these and prepare for the class. Normally, I don't think it will take much more than an hour. I don't think it's unreasonable. It often won't even take that. Now, so I actually just told you what my teaching philosophy was, but you can also, don't have to trust me on it. There's actually a Harvard meta-study that was done that showed that flipping classrooms is a superior to just doing passive listening. Now, the grading for the course is broken down. There's 2 midterms and a final worth 60% of the grade. The final is not comprehensive, so in effect it's a 3rd midterm. Lab participation is 5%, and that means you complete the assigned top coder or challenge problems in lab. The participatory activities are the ones you'll be doing before class, and the challenge activities are the ones you'll be doing during class, and sometimes a little bit after class if you haven't completed it. Then the labs are worth 25%, and that comes to 100% overall. Here's the grading scale. It's pretty standard for UT. I give pluses and minuses if you're near the top or bottom of the range. So generally this doesn't happen, but if you miss an exam without a valid excuse, you receive an average for the remaining exams and a 1 letter grade reduction, say from a B plus to a C plus. Probably half a letter grade. I always think that's a little draconian, but probably half a letter grade. Okay, assigned readings for the course are under lecture notes. So every class there's a textbook reading. In general, as I said, you should have completed that textbook reading before class. Today's the August exception. And I will expect you to do these activities, just do them before next class. And then for next class, you'll read these topics and do the participation activities. I tape my lectures, so if you miss a class, you can see what I was talking about. These lectures are from the past. This is empty because I am recording right now. So in general, the lecture from the previous semester will be there and will get replaced with the current lecture after class. There's also some online notes. So my course follows the notes for another professor, Dr. Plank. He teaches the follow-on 302, so I like to keep in touch with what he does. He often has more detailed examples. So while the book is aggressively minimalist, hitting you with essential information, his notes kind of fill things out, give it character, and give you some more detailed examples. And sometimes also, his notes contain material that are used in the lab. So you also need to look at his notes as well. And generally, my lectures cover the online notes, which complement what have been assigned here. So these are more getting into detailed examples and things that you need to know for labs, which complement the basic knowledge you're getting here. Now, for the first, as I said, first month, we essentially cover stuff that you've already seen. So input-output next time, string and vector basics a week from today. String streams, something you saw toward the end of 102. Vectors, procedures and functions, and strings in more detail. Then classes and multiple files. So it's actually not until February 8th that we get to hashing, which is the first data structure. So the first month, we're reviewing and deepening your C++ skills. Then we get into the data structures. And you'll see that actually much of the first midterm covers just a review of your C++ skills, which is also a deepening of them. Then, as I say, we get more into the heart of the class where we're covering different data structures. By the way, feel free at any point to stop me and ask questions. Very much open to questions. Okay. Don't really need to worry about Topcoder right now. We'll get to that in lab in 2 weeks. Topcoder is a site that offers up somewhat challenging short problems that will help you with problem solving, where the problem solutions are fairly short, but it requires a little thinking to solve them. So these are meant to give you practice with problem solving. Then there are practice problems, and actually over the break found another site that has practice problems. So sometimes students ask me, is there a place where I can find practice problems? I'm actually going to change this link because or add to this link because there's a good site for that. The exams are always a two-part process. They are an in-class exam that is paper and an in-lab part that is coding. So I find that you can, when you're able to actually code, try things out, I get much better results than if I simply make you write out the programs in class on paper. And generally, an added benefit is that it's a lot nicer to read typewritten code than it is to read your handwriting. Okay? Most of you use Code Assessor in 102. We use Code Assessor as well in 140. I actually developed Code Assessor with some senior design students 5 or 6 years ago. It works very nicely. Now, unlike in 102, in 140, some of you won't complete the problems on the exam, and then we look at it. We actually look at the code and take away points or add points based on style. Sorry, I did not silence my phone, which I will be doing right now. Meant to have Do Not Disturb on. Okay, so in lab, you will have the coding problems. In class, you will be doing the more conceptual part of things, code reading, answering what the data structures often will say, here's a bunch of inserts, what's the data structure look like after this set of inserts? So there are practice exams that you can look at, and when we get closer to the date, we'll have more information. And then the TA information link is not yet current. The TAs are still setting up their office hours, but once they have set up their office hours, we'll have a link to them with their email addresses. They will be holding their office hours in MinCal 217. The reason is the programming clinic gets kind of crowded. So it will be MinCal 217, which is the student organization area downstairs. So you might want to write that down. That's where the TAs will be holding their office hours. Okay, if you go to the programming clinic, you won't see them. They won't be there. So, questions about any of this? Okay, the last thing is the labs. So here's the lab assignments, all kinds of information about the labs. The big thing is that there is a extra credit lab in effect because the lab scores come out to 1,200 points, but that's divided into 1,100 points. So you can actually get almost a 10% bonus on your labs by completing all of them. Or conversely, if you need to miss a lab, then it doesn't hurt you. You can still get to 100%. So that's the point with the labs, yes.
So you cut off a bonus point at a certain point. You can't like get over and like get some calculated your final grade.
No. You can get up to, if you get 1,200. Actually, I'm going to have to recheck this. I just remembered that. This one is from the fall, and we usually have one more lab in the spring. So it's probably going to be 1,300 out of 1,200. But the answer is no. If you got a perfect, say, 1,200, then you would end up with something like 110% for your lab, and that would boost your grade in the end. Yep. So it's, yes. So that's, or if, as I say, it gives you a way to, if you miss a lab, it's not killing you. So, okay. But that's also why I'm not big on extending labs for people, because we do have this cushion. You will note that the labs are typically due at 6 a.m. So when you see that it's due on Monday, January 15th, that's not really true. It's really due the evening of Sunday, January 14th. But many computer science students are night owls and like being able to work into the wee hours. So I make the labs actually due at 6 a.m. Don't get head faked into thinking, oh, it's due Monday, January 15th, and at noon on Monday, January 15th, start working on the lab. Not only is that bad practice, but you'll already be handing it in late. So really, when you see these due dates, it's really due the evening before. Okay, and generally labs are due, actually this is not right. I want to make them generally due before the lab. So some of these early ones are going to change. Not this one's not, but some of these others, starting with lab 1, they're actually going to be due Wednesday morning, not Thursday morning. There we go. Most of them already are showing as Wednesday morning. These will be changed to be Wednesday morning as well, so that you actually have finished it before you come into lab. You're ready to do the next lab. Let's see. Make sure you comment. So we run what are called grade scripts, and correctness is 80%. So we show you in advance. We make no bones. We give you the test cases. You know when you submit what your grade is as far as correctness. You'll know how many test cases you're passing. Then 20% is for commenting and programming style. Is it well organized? Is it well commented? Just like an English paper. You can organize it and present it well, or you can organize and present it poorly. If you organize and present it poorly, you will be penalized. Conversely, if you organize well and present well, you will be rewarded. So do look at the commenting and programming style. I'm not going to go over it. It's much like in CS 102, so you should be pretty familiar with it. Getting lab help, you can visit me during my office hours. You can visit the TAs, not in the programming clinic, but in MinCal 217, so I'll change this. Or you can post a question to Piazza, especially during the weekends. That is a good way to get help. Now, both me and the TAs also have other activities, especially on weekends, so you shouldn't expect prompt responses on the weekends, and it obviously will be sketchier during the evening. Now, I strongly encourage y'all to chip in and help out your fellow classmates. That's what Piazza is meant to do. And at the end of the semester, when I'm looking at whether I might be rounding up your grade or not, if you've done a lot of participation on Piazza, I'm going to be favorably disposed to increasing your grade. Okay, but don't expect fast response in the evening or on the weekends. The TAs have classes. I'm a married man. My wife doesn't expect me to be sitting at the computer in the evening or on the weekends. She expects my time. So you'll get definitely much faster responses during business hours. Okay, some general stuff. First of all, this comes up every semester. It's fine for you to develop your programs on your machines, but they need to compile on our Hydra machines because that's what the TAs will be compiling on. And if they compile on the Hydra machine and it doesn't work, doesn't compile, you're getting a 0. You can then demonstrate to the TAs that it compiled on your machine and that some slight modification will make it compile on the Hydra machines, and you'll get your points back minus a 10-point deduction. Please don't put the TAs through that. Make sure that your code compiles and works properly on the Hydra machines. So not only must it compile on the Hydra machines, it must execute the test cases correctly on the Hydra machines. Okay, so that's also point 3. Always test your code on the Hydra machines. Okay, keep up to date with class announcements on Piazza. That's where I announce stuff. So make sure that you're registered on Piazza. That's where I do my clarifications for labs, answer questions, so on and so forth. Okay, and Camille posted some nice things for VI and UNIX to Piazza yesterday. I encourage you to look at her post. I have my own so-called cheat sheet for VI. GDB will go over at another time when we get more into debugging. So questions about anything? Okay. Today will be the one time where you do have to endure a lecture for the entire class. So we do have another 25 minutes, and I did just want to briefly talk about what is in the notes, UNIX Bi Files and compiling. Most of you already went through VI yesterday in lab. So I assume that you've already seen most of that. So where you are and where you're going, we talked about. Where you were is with graphical operating systems and development environments, and where we're going is to the command line. Now, did they talk to you yesterday about how you can get terminal windows on Windows and the Mac? Okay, good. I won't go over that then. If you didn't attend yesterday's lecture, look at the notes here because they give you a way to do it. The TAs will also be soon holding office hours, and you can talk to them about how to get terminal windows. Same thing with learning Unix. Initially, it helps to have a cheat sheet nearby because it takes a while to memorize the commands. And it can be a pain in the neck to always be looking them up. So I actually suggest printing it out. I think it's better than always clicking somewhere. I think it's easier to just keep your hands on the keyboard, look over, find the command you want. And there are basic commands that you really are going to be your go-to commands initially. For UNIX ls, which is list a directory's contents. And remember, what is a directory the same as? A folder. And cd for change directory are two ones that are going to be your go-to staple with Unix early on. CD and ls. Change mode, they should have gone over yesterday with permissions. So you need to make sure that you are protecting your files from prying eyes. And the TAs told me they went over that yesterday. Now with VI, again, it's okay if you use TextEdit on the Mac or WordPad on Windows. We actually do think you should give VI a try. It is, once you get used to it, it is very quick. And actually Vim is the more recent version of it. So actually probably better to use Vim. I have my own set, again, of commands that I think are pretty useful when you're first getting started with VI. I'll actually probably put them up on Piazza. So one thing is that we want your code to be nicely indented, but it is often the case that when you're developing a program, you don't really want to worry about making it all nice and indented. Well, if you type the character sequence GG = G, it will nicely indent the code for you. Okay, so for example, let's get another window or tab here. Let's say I had I already have this program. Let's make it not be very nicely styled. So I just did it. It's not very nicely styled, this function. Now I do GG = G, and it nicely indented it. So that is a very quick way to indent your code once you're done. And don't worry about indenting it before that. Okay? Hitting a number and then G will go to that line in the file. So you replace that pound sign with a number. Like, for example, if I say 18G, it will go to line 18. Okay, so if I say here, this is the current line. What line are we on? 17 of 38. If I say 35G, it takes me to line 35. If I say 17G, it takes me to line 17. Very handy, especially when you start getting compiler error messages that say an error is on line 6. Probably the first thing you'll want to do is go take a look at line 6. The fastest way to get there, once you get into VI, is to say the line number and G, and you'll be there. Another useful command is the cut command. If you say some number DD, it will cut that number of lines to the clipboard. So starting from the current line. So if I say 5DD, it deletes those 5 lines. If I just say DD, it deletes the current line. And it puts it on the clipboard. How do I get back from the clipboard? You just actually saw me doing it because as soon as I took it away, I put it back. P pastes what's in the clipboard. So P pastes back what is in the clipboard. So if you need to move code around in Vim, then DD will allow you to cut the lines to the clipboard. P will allow you to paste them back somewhere else. If instead you want to copy instead of delete, code yank, YY is called yank. I don't know why, but I guess they use C for something else, so the number is the number of lines to yank. If you just say YY, it will yank 1 line. And that's a copy as opposed to a cut. Now it's also nice to be able to find things. You often have a search button in your WYSIWYG editors, and to find something in VI, you hit the / and then you give the word you want. So let's say I want to find given. I hit down here, you can say I'm typing GIVEN after I entered the / and when I hit return, it takes me to the next instance of given. And now if I hit N, it will take me to the next instance. Turns out there's only 2 in this file. I take it there's 3. So N takes you to the next instance. P, whoops, not there. That's right, P is paste. Next, capital N will take you back. So lowercase n takes you forward, capital N takes you back. Okay, if you want to go to the beginning of the line, 0 takes you to the beginning of the line. Hitting the $ takes you to the end of the line, which is nice. Also, you sometimes mess things up, like I just did when I said P would take me someplace. When it was capital N, P did a paste, and I didn't want that. So I typed a colon and then undo, and it undid the last command for me. Okay, so I'll post this on Piazza. These are my handy VI commands that I think you'll find useful early on. Okay, as you get into it, you'll memorize more and more commands. I think these are real handy ones to prioritize in terms of memorization. Okay. Obviously, WQ for write quit is a good one to remember. Okay, so that takes care of VI. And that brings us to the last topic for today, which is files and compilation. So when you were using CodeLite, you compiled by going to a menu and popping down the menu, and it would have options for like compile or compile and execute. You don't get that with Unix. You're going to have to type in a command in order to make the program run. So the command that you'll be typing in is G++. So let's go back to play. Let's just do a very simple hello world program. So I for insert. Okay, so here's a very simple program. I'm going to write and quit it. It should print out hello world. So the way I compiled it is with G++. If I give the command G++, it's going to take a moment. It always takes a moment the first time, but then afterwards it seems it's loaded G++ into memory. So I think initially it's on the disk and has to be paged in. That takes a moment to get it off the disk. After that, it's in memory and it's faster. So it finished it. The question is, where's the file? The file is in a location called a.out. Why a.out? That's what the designer of the original language C chose to name the file, and the developer of C++ went with that convention. So it's always a.out when you do G++. Now if you just try to type a.out and execute it, it doesn't work. It says command not found. So one thing you quickly learn is that in Unix you have to put a dot and a / in front of the file name in order to make it run. And you see it just ran and printed out hello world. So the dot says to look in the current directory. The /, that's what we always do with CD, says that is the delimiter, in effect, and that's the name of the file. Look in the current directory, the delimiter, here's the file name. Now, that's not very convenient. Why is that not very convenient to have everything named a.out? Does anyone know why?
You could be compiling multiple programs.
You could be compiling multiple programs in the same directory. Each time I compile a different program, it overwrites the previous program I compiled. Not only that, so that's the reason, but another reason is that's not very descriptive. Okay, we actually probably think of the program as hello world. So, Unix commands typically have what are called flags, and G++ is no different. If you say -o, so dashes in front of things indicate a so-called flag or input to the command. It's a parameter. Just like you pass parameters to functions, you can pass parameters to commands by putting a dash. So this says that I want to name, the -o says what I want to name the so-called executable file. So what .cpp gets compiled into is called an executable file. We want that executable to be named hello world. So we use what's called the -o flag to name it. In this case, we're saying the name is hello world. And then we give the name of the program we're compiling. And if I now say hello world, it works. Okay, so generally when you compile, it will be G++ -o, the name of the executable that you want the compiled program to be put into, then the name of the program you're compiling. Okay? Don't mess it up. If you say G++ -o hello world.cpp, hello world, you're going to be very unhappy. There's a good chance hello world.cpp will get clobbered. So you need to be careful about that. Okay, so that's G++ is how you compile. Now, one thing you're going to very quickly run into are bugs, compile errors. So let's leave a semicolon off and try compiling. Now, as you get better, you will see things that are shortcuts. I could retype G++ -o. Or there is, if you start using the arrow keys, you can cycle through previous commands. Ooh, that's nice. By going up, I use the up arrow 3 times. You can't see me doing that, but all of you have 4 arrows on your keyboard. If you go up at the command line, it shows your previous commands. If you go down, it cycles through in the other direction. Or if you want to look at your previous commands, the history command will print out a history of your previous commands. And instead of cycling, you can then say bang or exclamation mark and the number of the command, which in this case is 563. Bang 563 will execute this command again. Very handy. Or, what is more common, you can start bang and then the first few letters of the command that you want, and it will find the most recent command matching that. So the most recent command matching bang G is G++. Actually now it is 567 is G++. But in any case, this will also work. So nice keyboard shortcuts. Starts with the exclamation mark, either the number of the previous command or the start of the previous command, and it will find the rest of it for you. So this has now an error. Sometimes you get nice error messages like this. So In this case, pretty obviously, I expected a semicolon after this particular statement in hello world.cpp at line 5, character position 27. This is pretty useless. This is pretty useful. So line 5, so we go to VI. Notice again I use bang V because I know it's going to go straight to my file. And what command will get me directly to line 5? 5 capital G. And what will get me to the end of that line? $sign. Now, do you remember from yesterday what the command is to start appending? It is I for insert, A for append. Okay, the difference is if I do insert, it's going to insert before the colon. If I do A for append, it's going to insert after. It's just whether you want to insert before or append after. And what's the command for getting out of insert mode or append mode? Escape. Okay, so let's just make sure that that took care of the problem. And it did. So sometimes it's not going to be quite as nice about it. In fact, here I'm going to go to Dr. Planck's notes. Let's see. Actually, let's try taking away the quote. So I took away the quote now. Yeah, it's a lot better than it used to be. Okay, this was very nice, but sometimes you get a very long laundry list of what you did wrong because the errors start cascading. Once the first error occurs, the compiler tends to get confused and it starts to print out a lot of other error messages. Typically, these other error messages are being caused by the first error message. So when you're trying to fix your syntax errors, don't start at the bottom. Start at the top. Generally, you should only fix the first error at the very top, because generally a lot of the other errors will go away once you fix that top error. And even if they don't go away, it's usually a different set of errors you're going to see because the next error is going to introduce a different cascade. So the way to fix your syntax errors, look at the top error, go to that line, fix it, then recompile. Don't say, oh, I'm going to fix all my other errors because probably all the other errors are a consequence of this first error. The compiler gets confused very quickly. Once it doesn't see this quote, it's very hard for it to recover. Okay? And it starts making assumptions. Those assumptions are often wrong, and it starts producing nonsense. Now, there's one other error that you should be familiar with. Let's call a function foo. Let's define the function foo. You may remember that you can declare functions. So I've declared the function and I've called the function. What's the problem? Haven't defined it. You might, obviously here, you're not going to forget to define foo, but in big programs you sometimes forget to define a function. You declare it, but you forget to define it. This is a somewhat different kind of error message. Undefined symbols for architecture. Well, this is just the chip I'm running. Foo, reference from main, and notice it didn't give me a line number. That's unfortunate. There's no line number. LD, symbols not found for architecture, clang, error, linker command failed with exit code 1. So what's going on here? It turned out the program compiled. and the compiler punted to the linker the problem of resolving foo. So there's actually two things that go on in compilation. One is the compiler compiles a file, and then a linker comes in, and it tries to resolve what are called function calls. So it links the call to the function. Well, in this case, the compile worked, and it punted the problem of finding the function down to the linker. The linker couldn't find it, and so it produces symbol not found. So when you see this error message, it's different. It means you forgot to define the function. Why am I showing you this? Because nowhere here in this error message did it say, hey, you forgot to define foo. Nowhere in here did it say, you forgot to define foo. So you need to know how to interpret this message. This message means you forgot to define foo. Okay? You're not getting a line number, so you're not going to know where it was called from. But any place you called it, it wasn't found. Okay, Clang is actually the name of the project the Macintosh uses to write the compiler. There's two competing groups, Clang at the University of Illinois, GNU, which is an open source thing that originated at MIT. So when you type G++, it stands for the old GNU C++ compiler, but I run on a Macintosh, and it cleverly substituted this Clang for G++. At any rate, that's the meaning of this. Okay, so for next time, a reminder that I do expect you to read today's assigned textbook readings, do the participation activities, as well as do the readings for next time and the participation activities before class. If you have an issue with the ebook, let me know, and I will try to put you in touch with someone at the bookstore who should be able to get your problems resolved for you. Oh, and a final thing, this lecture will be going up by tonight. So by tonight, this lecture hopefully will be up for you.
That's a good question about the left zero.